This enterprise architecture, first time, if you go with technical documentation, you will get these points. First time, approach came to create an enterprise architecture. These are the features of enterprise architecture, right? So how to create that enterprise architecture? We need that enterprise architecture that should have these features, right? So how to create that? If you remember, Oracle database first time, created for US Army. Oracle was a database, right? First time it created for US Army, and this database was the relational database, okay? RDBMS. And this first time this RDBMS concept came, in the year nearby 1997, 1996, that's sorry, 1976, 77, that time. Relational database concept first time came. So what they tried is that they tried to use this database. Database means RDBMS. This RDBMS, they try to create as a global schema, and that schema should manage the application that will run worldwide. So that was the approach that is started in the year 1980. And the name of that particular project is EDM, Enterprise Data Model. So they try to use database to create a global schema as an enterprise architecture that will manage the application that is running worldwide. That was the approach first time, came, to create. But ultimately, it was not successful due to different vendor complexity, multiple dependency from different vendor, different type of interest from different vendor. Ultimately, it was not successful to create an enterprise architecture as the database, RDBMS, as a global schema. It was not successful. Fine. So then in the year 1990, just 10 years back, 10 years after that, you may heard the name of ESB. ESB full name is Enterprise Software Bus. ESB full name is Enterprise Software Bus. Now, not Service Bus. That time when the name came, Enterprise Software Bus. So that time, you'll find this product, CORBA. CORBA full name is Common Object Request Broker Architecture, CORBA. MOM, Message Oriented Middleware. XML Web Service. These technologies came, to create, to implement. This is not 1990 nearby, So in that particular time, so this technology actually used to create distributed environment communication. Distributed environment means how two systems is going to communicate with each other, right? That is distributed environment communication, right? Calling the functionality in the remote system, remotely calling some functionality, or the functionality from running in one JVM, calling the functionality that is running in another JVM. That is the idea when distributed, where two systems is going to communicate with each other. So this technology came to implement distributed environment communication between multiple systems. And these technologies are in the middle tier, right? Middle tier. From Java, you can create XML web service. From some other language also, you can create XML web service, right? So nearby. So this time it came, and so it is in the middle tier, not in the database tier. First time they try to use the database global schema, right? So in the next time they try to use these technologies to create an enterprise architecture that will manage the application that is running worldwide. So this technology they try to think about as like a global software bus or as an enterprise software bus. They try to create a enterprise architecture that will manage the application that is running worldwide. But ultimately, this was also not successful. To create an enterprise architecture, not successful, but this technology that you find, these technologies are very much successful to create distributed environment communication. These are the technologies being used to implement distributed environment communication. Still now, right? We use XML web service. CoreBuy is not used today. CoreBuy is now legacy. MOM is also being used, but most of the APIs are legacy today. Right? So ultimately, these technologies are not, successful to create an enterprise architecture, but they are being used very much successful to implement digital integration in distributed environment communication. Right? Fine. Next came in the year 2000. So in this 2000, we find first enterprise architecture. Its name is SOA. SOA full name is Service Oriented Architecture. So when I say service oriented architecture, service means web service. When I say service oriented architecture, service means web service. Right? Now, this service oriented architecture that came in the year 2000, that is based on middle tier logic. So what is service? Service, web service. Web service means what? Web service means what? You are exposing the functionality as a vendor independent component. You can write the functionality in Java. You can expose that functionality as a vendor independent component. You can write the functionality in .NET. You can write the functionality C++. You can write the functionality PL/SQL. Whatever the functionality is there, that functionality you are going to expose as a vendor independent component using web service. That is web service, right? So what they have done in the year 2000 is that middle tier logic they exposed as a service or web service, and that service is there inside SOA, service oriented architecture. They'll give one type of centralized repository, and that repository is used to manage the application that is running worldwide. So this SOA came as an enterprise architecture in the year 2000, and it supports all the features. Just now I told you, right? Enterprise application features. SOA supports all the enterprise application features. And it is very much successful enterprise architecture today also. Some of the, now when this SOA came, in the year 2000, then different vendor came with their own product. Oracle came with their Oracle SOA as an enterprise architecture. IBM came with IBM SOA. Apache came with Apache SOA. Microsoft came with Microsoft Dynamics. So all the vendor came with their own SOA. Even they are being used till today. So SOA is a successful enterprise architecture. Okay, that came in the year 2000, means from now 22 years back. Right, and Oracle SOA till today, Oracle SOA 12c is a very high demanded product today as an enterprise architecture. Right now, this SOA that we're talking about, it's successful, but the problem is that with SOA, if I'm going to implement SOA is not SOA different vendor came with a different product. But I'm taking an example. Let's say about Oracle SOA. If I want to implement Oracle SOA in a particular business, so this need a big resource. 30 to 40 resources required to handle the SOA project, minimum. And the SOA is mainly used SOAP-based web service, XML coupled. SOAP-based web service, Now see, there is, SOAP-based web service and REST-based web service is there, right? So if you go with SOAP-based web service, you cannot be very easily work with SOAP-based web service, but you can very easily work with REST-based web service. There is some reason, because to work with SOAP-based web service, you should be a very good and excellent XML developer. Because web services are SOAP-based and you should be a very good XML developer, then only you can work with WSDL files of SOAP web service. So these are some of the limitations with SOA. To resolve any customer requirement, if you want to resolve any customer requirement with SOA, it takes 1.5 months. Means the requirement you have to resolve, then you have to implement in the testing phase, you have to implement in the development server, you have to implement in the production server. All those phases to complete, it may take 1.5 months. So this SWAP is not for small project also. I'm talking about a small Oracle 12c SWAP. Big projects comes under this. So due to this, uh, limitations, you can say, you need more resource, right? We cannot come with customer requirement very fast, right? Customer will not wait 2 months to come with the solution, right? Customer will say, give me this solution within 2 weeks. This is the customer requirement as early as possible, right? So we should not have technology too much complex. Right? So based on that point of view, this microservices architecture came. Okay. Now this microservice architecture, you'll go with different technical documentation, and different technical documentation will tell you different date and time. Now, I'm just talking about from one of the important technical documentation where Martin Fowler, Martin Fowler, his name, he was the creator of your HTTP specification. Now, he was going with a workshop in the year 2014. Okay. And in that workshop, that microservice concept came first time, that name microservice. So based on that, you're talking about that from that time, 2014, it started to get popularity. Then after that, different clouds implemented microservice in their project. Different cloud, AWS, Azure, Google, everyone implemented microservice. Now, this microservice is also, being created using military logic. As the saying, microservice. Service means what? Web service. You can say micro web service. Web service, in case of microservice, you always use REST-based web service. So you can say micro REST web service, something like that, right? So microservice always deal with REST web service. Okay. So in case of REST web service, you'll not find XML coupled, because REST web service always use JSON to exchange message, right? JSON is a key value pair. So to learn JSON, it is not too tough. JSON is just a key value pair in the curly brace. That's it. JavaScript object notation, right? But to learn XML, it is not easy. If you say I know XML, that means you have to know XML well-formedness of your XML document. You have to know how to work with XML namespace. You have to know how to work with XML grammar, because for each XML document there should be a schema, right? You have to know how to get the data from your XML document. You should know XSLT, XML style sheet language transformation. You should know XPath, how I can get the data from your XML document to generate another one XML document. So when I say that I'm a good XML developer, you should know all those things to exchange the data, right? Whereas when you go with REST web service with JSON, you don't have to know all those things. In JSON message, if you see JSON message, just a key value pair in a curly brace, that's it. Yes, there is something is there. You have an array of JSON objects, but it is not that much of complexity like XML, right? So that's why, we are moving with microservice. That is nothing but REST web service that is used to exchange JSON message. It is not that always JSON message is being. If you want, you can exchange a XML message also using REST web service. But industry is moving towards REST with JSON. Right. So that is microservice is also being used with REST with JSON. Right. So this is how the things came one by one. If you think about the historical side. Now we'll say that then why I'm moving for the timing, just I'm telling you, since talking about it. If you go with microservice, I'm talking about a small project. A small microservice project can be handled very easily with 8 people, 8 resource minimum. Number one. Number two, to resolve any future customer requirement, you don't need to wait 1.5 months. Within 2 weeks, all the process can be done. Minimum requirement I'm talking about. Right. So we need less resource. We can resolve customer requirement. And this microservice work also too easy. I don't have to be an excellent XML developer to work with the SOA project. No. If you know basic web service using REST, web service communication using REST, you can work with microservice project. Just know the concept of JSON. That's it. Right. So it is very easy to work with also. Right. Right. So that's why, when we are moving towards microservices architecture. Right. But there is lots of things to know, to understand how microservice architecture work. Right. So that things we are talking about into more details in the coming slides. Right. So let's move to the next.